With each improvement in its innovations, SpaceX takes mankind one step closer to achieving the goal of interplanetary transportation. Recently, that improvement came in the form of a new generation Raptor engine that is poised to revolutionize space travel and disrupt the industry completely. The new improvement in the new engine is technically something to marvel at, and only leaves one main question in the minds of experts and analysts. Just how far can SpaceX keep pushing the boundaries with this engine? In today's episode, we get deeper into the details and get to see how far the company has come with this engine and what the future holds. Stay tuned. At the moment, SpaceX has three versions of the Raptor engine. That is the Raptor 1, 2, and 3. However, with the rapid improvements that the company is doing on the Starship, it goes without saying that there will soon be a need for a new engine that will meet the energy requirements of the improved vehicle. Now, after news of the development of Starship V3, speculation on the type of engine that will power the new vehicle only got amplified. However, to understand why many people see a need for new engines to power Starship V3, we have to look deeper into what this spacecraft will be. At its core, Starship V3 is a better version of both Starship V1 and V2. Although SpaceX has remained economical with the specific details about the spacecraft, it is more likely than ever that it will be up to 95 feet longer than the current 120 meters. Now, this is in line with an earlier tweet by Elon Musk, where he confirmed that the new spacecraft is set to be between 10 to 20% longer than the previous generation spacecraft. In addition to that, it is now apparent that the Starship V3, when used as a tanker, will be in a position to comfortably carry close to 200 tons of payload to low Earth orbit. In other setups, its payload capacity will differ, but is expected to be much greater than earlier versions, thanks to its larger size and enhanced thrust. That last part, touching on enhanced thrust, brings us to the most important part of this video. How will it attain the enhanced thrust? Is it through an increased number of already existing engines? Or is SpaceX looking to develop a new generation power plant that will produce the required thrust to get Starship V3 to the moon and beyond? Now, the SpaceX Raptor 3 engine demonstrates exceptional efficiency and power. With a thrust of 280 metric tons and a specific impulse of 350 seconds, it achieves high performance while maintaining a lightweight design. The engine generates approximately 2.75 gigawatts of power calculated from the thrust and exhaust velocity. Its advanced manufacturing, including the use of 3D metal printing, reduces weight and complexity, resulting in a mass of only 1,525 kilograms for the engine itself and 1,720 kilograms when including vehicle side component. These improvements have undoubtedly marked a significant step forward in propulsion technology. And now, as it turns out, Elon Musk has hinted at exciting developments regarding a potential new engine concept that he referred to as the Raptor 3X. This engine, described in Musk's tweets and recent SpaceX discussions, aims to build on the substantial advancements made with the Raptor 2 and Raptor 3 engines. You see, while the Raptor 3 engine has demonstrated significant performance improvements, particularly in thrust and efficiency, Musk acknowledges that there is still room to optimize its mass-to-thrust ratio. The Raptor 3X, according to Musk, could achieve a thrust-to-mass ratio exceeding 200, potentially generating up to 10,000 tons of thrust at liftoff. This would enable even larger payload capacities or reduce overall launch costs, enhancing the SpaceX's Starship system and its interplanetary transport objectives. Additionally, there is speculation about improvements in specific impulse, which measures engine efficiency, with a gain of up to 5 seconds predicted over its operational lifetime. A key point to note at this point is that the improvements in the new engine-specific impulse indicate enhanced efficiency and how the engine uses fuel to generate thrust. A higher specific impulse means the engine can produce more thrust per unit of propellant, thus reducing the amount of fuel needed for the same performance. This is poised to have a significant influence on mission feasibility by increasing payload capacity, extending range, and more importantly, lowering cost. Such advancements are critical for interplanetary missions and reusable rocket systems, and achieving them positions SpaceX even closer to achieving its quest to take humanity to the lunar surface and beyond. Another critical part of the new engine that we have to look into is the materials that SpaceX will use in its manufacture. Of course, it is expected that we will see some more advances in additive manufacturing, particularly 3D printing, as the company pushes for two key achievements: reduced weight and enhanced efficiency. With that in mind, we could see an increased use of materials like high-performance alloys, such as those used in earlier Raptor versions, only that these will now be more optimized for extreme temperatures and pressures associated with the new engine. For instance, materials such as inconal superalloys, specifically inconal 718 or proprietary SpaceX-developed versions like SX500, will most likely be used for combustion chambers due to their impressive heat resistance and strength. On the other hand, SpaceX might decide to use high-conductivity copper alloys for cooling systems to dissipate heat effectively, while titanium could serve as a lightweight protective shell to endure mechanical stresses. When it comes to specific components, the company might decide to go with a combination of carbon fiber composites and niobium alloys. With these options, it will guarantee an optimized performance of the engine under varying thermal conditions, a critical aspect for reusable engines. Additionally, we could be set to see SpaceX improving their pre-burner synchronization system, as this could help in making a significant step toward enhanced efficiency and reliability of the new engine. The pre-burners, which prepare the fuel and oxidizers separately before they enter the main combustion chamber, must operate in perfect harmony to ensure stable combustion. Any delay or mismatch between the fuel-rich and oxidizer-rich pre-burners can cause mechanical stress, inefficient propellant usage, or even system failure. By introducing advanced feedback control mechanisms and real-time synchronization technology, SpaceX could achieve more precise operation during critical stages such as ignition, throttling, and shutdown. This advancement will help to minimize wear and tear on engine components and, at the same time, reduce the risks associated with high-thrust operations. This improvement will also serve to enhance the trust levels among the public that the engines powering these spacecrafts are reliable enough to power the vehicles during interplanetary missions when that time comes. However, we cannot overlook the possibility of the company deciding to capitalize on the existing engine version. This means that it could consider using more versions of the existing Raptor engines. This approach would allow the company to leverage the existing Raptor technology, thus reducing research and manufacturing costs, while ensuring the spacecraft meets its performance goals. The key to this strategy would be ensuring that the number of engines is appropriately scaled to provide the required thrust for Starship V3, all while maintaining efficiency and reliability for each launch. The approach is consistent with the proven strategy of reusing components to drive down costs and increase production speed. As SpaceX keeps pushing the limits of innovation and physics with the new engine, it must also ensure that it aligns its practices with sustainability goals. To do that, the company will need to focus on reducing the environmental impact of its operations, from engine manufacturing to launch practices. One key area to target is making the Raptor engines even more reusable by improving their lifespan and reducing the need for major overhauls after each launch. Now, apart from using more durable materials, it could look into the possibility of using more sustainable fuels, like liquid methane, which burns cleaner than traditional rocket fuels, and consider optimizing fuel efficiency to reduce waste. Moreover, developing more energy-efficient production methods for building engines and spacecraft will help lower the carbon footprint of the entire manufacturing process. SpaceX could also explore options for minimizing the environmental impact of launches themselves, like refining engine emissions and exploring cleaner propulsion technologies for future missions. Now, all we have to do is wait and see the kind of engine that SpaceX will come up with for the spacecraft. However, one thing remains clear: the new engine is bound to push the limits of physics to unprecedented levels. Subscribe to the channel for more videos like this.